In modern mathematics, we call every mystery we cannot solve or name X. In algebra classes, in equations, in every complex problem written on the board, that famous unknown is there. But when did humanity first start looking for this X? To find humanity's discovery of the concept of the unknown, we need to go back 3,700 years in the pages of history. They did not call this unknown X, but Ka, meaning heap. The Aha problems found in Egyptian papyri represent one of the oldest algebraic practices corresponding to the solution of linear equations containing a single unknown. Today, we are not just solving an equation, we are exploring the mind behind history's first heap, the scribe Ahmes, and the birth of the unknown in mathematics. The Rhind Papyrus, written around 1650 BC, was not just a dusty mathematics book. As researchers emphasize, it is a great mistake to read Egyptian mathematics solely through numbers. It is necessary to contextualize these texts alongside administrative and economic life. For Egyptian scribes, mathematics was applied engineering that turned the wheels of the state, used in areas such as trade, travel, and architecture. Today, we calculate with an abstract letter X because we do math on paper. But in ancient Egypt, math was physical. The wheat harvested from the field, the bread distributed to the pyramid workers. That is why, instead of an abstract letter, they found a physical equivalent for the unknown, Aha, meaning a heap. Aha problems prove that the Egyptians were able to solve these linear equations with a single unknown, which they called Ka. Now, I want you to step into the shoes of a scribe from 3,700 years ago. You are faced with this problem. A quantity and its fourth added together become 15. The scribe Ahmes wrote it exactly like this on his papyrus. In today's symbols, we would say x plus x divided by 4 equals 15. Now, stop. Forget the rules of algebra, the x's, the cross multiplications. Imagine you are dealing with a physical heap using only your logic. How would you solve this problem if you were them? With the modern methods taught in schools today, we handle this in seconds. We equalize the denominators. We say 5/4 of x equals 15. We isolate x and reach the result. For us, this is just a standard equation solution. But what about Ahmes? Thousands of years before the invention of symbolic algebra, how did he find this heap? This is where a traditional explanation in the literature enters the stage of history, the false position, or Regula Falsi method. The traditional view is that the Egyptians used this method of false position to solve Aha problems. The scribe would first determine a guessed heap for the unknown, deliberately false but very easy to calculate. For example, he would say 4 for the heap. 4 and its quarter make 5. However, the result needed to be 15. At this point, he would scale his guessed number proportionally to the value he actually wanted to reach, meaning he multiplied it by 3 to find the true heap, which is 12. For years, everyone thought Ahmes used this proportional method. There was an almost universal acceptance regarding the use of false position. However, in 2020, researcher Bertato presented a very strong piece of evidence that shook this universal acceptance to its core. By directly translating the hieratic and hieroglyphic versions of Aha problems 24 to 27 of the Rhind Papyrus, Bertato provided evidence that the Egyptians did not actually use false position. According to him, Ahmes's solution pointed to a completely different and alternative algorithm, contrary to the traditional false position interpretation. Today, scientists are still debating between the lines of these ancient papyri about what that real algorithm in the scribe's minds actually was. Perhaps Ahmes was just setting up a proportion in his mind, or perhaps he was expanding the heap piece by piece. Today, we didn't just solve an old equation here. We witnessed the beginning of algebra, the birth of the concept of the unknown in the physical world. Because mathematics is not just about finding the right answer. Sometimes the greatest discovery is understanding how a mind that lived 3,700 years ago reached that answer. So, how did the Egyptian scribes distribute those strange, fractional pieces of bread that resulted from these calculations to the workers? See you in the next video, where we will set off towards the legendary Eye of Horus and the first computer algorithm history has ever seen. Stay with Limit and Beyond. Stay with mathematics.